chemistry topic by topic, and we're going to look at the chemical changes that take place. And we're going to start off having a look at the reactivity series. Reactivity series basically puts metals and a couple of non-metals that sort of part of the family, how they sort of react. We know that some metals are very reactive. We've looked in previous videos at metals like potassium and sodium, very reactive metals. But there are others that aren't very reactive at all, like copper, gold, platinum. If I were to go for a walk with you in Cornwall, maybe perhaps 5,000–10,000 years ago, we'd find copper lying on the ground, just native little bits of copper attached to a piece of rock, maybe. No chance now. But all the copper's gone. But maybe still people try looking in rivers and they look for the odd nugget of gold that might be coming down a river from sort of a gold seam somewhere upriver, and people pan for gold and they find bits of gold, and they find those bits of gold because gold is not very reactive. It doesn't really react with anything, and so we find it in its pure native state, whereas other chemicals we only find as compounds. Let's have a look at some of these metals and see how they basically compare with one another. And to do this, we're going to compare these metals, and I'll just choose 4 of them at random, and we'll have a look at some of those and we'll compare them when they react with something like hydrochloric acid. So let's go over and have a look at this experiment and see what goes on and what we need to do. Now, to do this, what are we going to actually use? Well, I've got to have some idea of some sort of method to sort of make it a fair test. And let's have a look and see what we've got. So if I have a look at what we've got a series of different metals here. I've got 4 metals. I've got here some zinc powder, and zinc metal powder is sort of this greyish colour. Feels remarkably heavy. You can't tell that by me holding it, but in fact that is quite heavy. Another metal, much heavier, this one than the zinc. This is copper metal turnings, and in here I've only got half basically full, but this is some bits of copper. Another one that I've got here, the one that you're probably more familiar with, iron metal filings. And so here some iron filings, something that most people are fairly familiar with. And the last one, we see magnesium as this stuff, magnesium ribbon, but in fact it does come in other forms, and here I've got a much lighter container, and this is containing magnesium turnings, which I've managed to spill. So we've got some magnesium, we've got some iron, some copper and some zinc, and we've got to find out which of those is the most reactive. To do this, we're going to react them with hydrochloric acid, and we're going to try and see what happens here as they react and what they do. But we've got to try and make this a fair test. So how can we try and make sure this is a fair test? One way is to make sure that we put in the same amount. So if I do this and we put in here into test tubes, then I could put the same amount of acid in there. And I could make sure we put the same either mass in or the same number of scoops in. So it doesn't really matter which one we do, we're just trying to have a look at which of these we can make into a reasonably fair test, and then we can try and draw ourselves out a table of results so we can work out which one is more reactive than the other. So let's have a look at this. Fair, we've got to try and do something to sort of make ourselves a little method so we can actually achieve this. So let's have a go and seeing what we can do to make this fair. Right, so we've got some metals, and we've got our metals. We've got copper, we've got zinc, we've got magnesium, and we've got iron. These are in no particular order, since at the moment I have no idea which is the most reactive and which is the least reactive. So there we are, there's my substances, having drawn it out. Now we're going to try and put them in here. So the quantities that we want, well, I could weigh them out in a balance here. I could try to sort of make sure I've got the same mass. I'm not going to do that. I'm going to just do it on a sort of a volume idea. But I'm going to make sure I've got the same volume of basically, can you do that? That's a phone coming in. Right, I have some problems with my phones at the moment, so they're ringing me on my mobile. Right, okay, so we've got the same volume, and we could do that with the same amount of HCl. Now I could measure this volume of HCl out. So I'm just going to use the same height in a test tube. We could measure this out accurate to the nearest centimetre cubed, no problem at all. So let's have a look at those. Now, what hazards are we going to have with this? Well, HCl is a little bit dangerous, and so I'm going to wear some safety specs. So I can put mine down here. There we are, there's my safety specs. I don't need to worry about really a face shield or gloves. It's not that dangerous. I've got water next door. So we can have a look and see what we can do. So we've got to try and compare these to see what happens. Well, let's have a go and see what we're going to do. So I've got my results ready to record, and I'm just going to make sure going the right way that I put my safety specs on, and then we can get started trying to do this experiment. I'm going to move my results right out of the way. So, to start with, let's have a look at putting in. I only need a small amount of hydrochloric acid here, so I've got a small depth of that. I'm going to put it in a big holder here, just so you can see it, because what I want to do is make sure that when I make the next test tube, it's got about the same amount of hydrochloric acid in there, and that will do for this sort of experiment that I'm doing. Fractionally more in that one than the next one. Let's just take a little out. There we are. It's better. And I'm only measuring these by eye anyway. Right, my acid is safe. I'm going to put it out of the way. So here are my test tubes, and what we want to do is put in a small amount of each of these metals. I'm going to see what happens. Now I'm going to get myself out some identical spatulas. If I'm going to put the same amount in, then I want to achieve the same sort of results. And having said I've got some identical spatulas, I've got two sets of nearly identical spatulas. Right, okay. Well, my first material in my list was copper, so let's take out some copper.
Okay, if we do that in an hour's time.
And no, couldn't show it to you easily. Right, just a small amount of copper. And I'm going to put a small amount of copper in there.
Yep.
And we're going to look at the reactivity of this one. Well, quite honestly, not a lot seems to be happening here. I'm not seeing any gas given off, no bubbles. I'm not seeing anything happening in the test tube, not seeing any tarnishing happening. Basically I'm seeing, well, nothing. It's not doing anything. Paul's just going to zoom in. I'll try and hold it still so you can see. And basically nothing is happening here. So it's really quite a boring reaction, this one. So we can put this one down as saying, well, copper, well, it's not very reactive at all. It does not react with the acid. So my next one on my list is zinc metal, and what I'm going to do is I'm going to take a small amount of zinc metal, about the same as I had copper. I'm just going to try and zoom in so you can see this. And let's add this to the test tube. So this is zinc metal plus the acid. Now I have to say that this is not looking terribly exciting. Now I was expecting it to be a little bit more exciting than this. But 2 molar hydrochloric acid, it's not really doing very much. I'm disappointed. I was expecting something to happen here. but it's not. Okay, so zinc plus HCl doesn't seem to be doing very much. Right, my next one on my list is magnesium. I have high hopes for this one. And again, we're going to take a small amount of magnesium, and I'm going to put that in the test tube, and Paul's just going to see if he can make sure that you can see this. Right, here we go. And instantly we've got something happening here. So we've got some sort of reaction, and I'm getting off some sort of gas. I don't know what that is. Maybe we ought to be able to find out what that gas is. But it's also getting very hot here. And I'm seeing some water vapour, some steam maybe coming off. Could be a gas that's been given off that I can see. But this is really quite a vigorous reaction. And it's abating slowly. So magnesium here, I've got some results for the first time. We've got something happening with my magnesium and my hydrochloric acid. So we can record that one as being quite reactive. And we're getting this white stuff at the top, and we also notice we got given off some sort of maybe steam and maybe a gas, but I don't know what it is yet. It's alright, I thought Paul was going to show you what I was writing on, he didn't. So I've just recorded that down here. Okay. Back to our experiment, and our last chemical we're going to try is iron, and let's see what happens if I take a small amount of iron and I react that with the acid. So let's just put it in and let's see what happens here. And as I was sort of guessing, because the zinc didn't seem to do much, the iron's not doing very much here either. I'm not getting really much in the way of reactions here. So that doesn't seem to be doing much. My zinc, however, I think this is actually now reacting very slowly. Let's zoom in here. I'll bring it closer. See if Paul can focus on this. We are getting something happening here. So I am getting some bubbles coming off. So zinc is sort of reacting, I would call it slowly. It's not vigorous, but I am getting some sort of reaction here. The copper still looking incredibly boring here, not doing much. And my iron, well, that doesn't seem to be doing an awful lot either. So I'll leave that one a moment longer. My magnesium has now completely disappeared. This is now quite warm, and I've got condensation in the top of the test tube. So zinc, we can say here we've got a slow reaction. Iron appears to do nothing, and copper appears to do nothing. Now I want to do one more little bit with this, because I want to try and identify what that gas might be if I've got this reacting. Have you got the lighter thing? Yeah. So we're going to do another reaction now, and we're going to do this magnesium and repeat this. I'm going to do it slightly differently, and what I've got out is my little lighter, because I believe the gas given off is hydrogen, and so I'm going to prove that. I'm going to take some acid, about the same amount we had before, a little bit more, and what I'm going to do is I'm going to put the magnesium in there, but when I do that I'm going to put another test tube over the top, and what I'm going to try and do is collect the gas, and we're going to verify that this gas is hydrogen. So let's have a go at doing this. So here's my magnesium, let's put it in, and immediately we've got some reaction going ahead, and if we're getting hydrogen gas off, hydrogen gas is lighter than air, so I would expect it to accumulate in this test tube up here. And to test for it, what I'm going to do is take a flame. Paul's going to, oops, we'll do that one again because I lost it all. So we'll accumulate some hydrogen, light the flame, and we got a squeaky pop showing that we collected some hydrogen gas. If we looked in the test tube, you'll also see there's some condensation which is formed by the water that's actually produced here. Going quite well. We'll try it again. No, didn't think I would probably manage it a second time, but we have got here, you can see some condensation formed. This is also quite warm, this test tube, because that's what the explosion was. We had some oxygen mixing with the hydrogen, we got that classic squeaky pop, and what we've got collected there is oxygen and hydrogen forming water when I put the flame there, setting the reaction off. So magnesium, significantly reactive. We've got my zinc, which is now going a lot faster, it's a lot better. I'm going to give this a little stir with the end of my spatula, just mix it up a bit, see if it's going to work any better. Bear in mind that's stainless steel and I've just put that in acid, so I'm just going to put that in the sink and we can wash that in a sec. And the zinc is reacting, we're getting some sort of here reaction. Problem with autofocus, it doesn't necessarily. So we've got some sort of reaction here, it's not terribly warm, so the zinc is doing something. Iron, on the other hand, is starting to react. I've got some sort of reaction going on with my iron. What I've got is, and I'm going to put it against a piece of paper, I've got a slight colour change here. Paul is struggling here trying to get the focus for you, but we have got some colour change. And we have got a few bubbles. So not a very quick reaction, but it is doing something. So I ought to change my notes here to signify this. So I've got some sort of brownish colour. Looks brownish. Could actually have a bit of yellow in there. I'm not really good. My problem is I'm colourblind, so it makes life fairly difficult for me to see. But we definitely have got some colour in there, and we've got some bubbles. So let's record that we've got a few bubbles. We've got a slight colour change. And that gives me my metals here that we can have a look at. So let's go and see what we've discovered. The experiment now, so it's perfectly safe to take off my safety specs. And let's have a look at what we've got. Well, if I wanted to try and put these in order, then if we do that with what we've got, copper didn't seem to do anything, so I could put that one firmly at the bottom. The magnesium reacted quite vigorously, so I'm happy to put that one at the top. And then I've got to look at what's happening here. Well, zinc's got a slow reaction. It's a little bit more than iron, not much. So I've got some reaction here with zinc, and I've got a little reaction with iron. So for my experiment, I've got these results. Magnesium being the most reactive, zinc the next reactive, then iron barely doing something, but doing a lot more than the copper. I expected my zinc to be more reactive than what we had, but we expect it to be fairly sort of low. I would expect them to give off hydrogen gas, and I would expect them with the acid to form something. So magnesium plus HCl, acid plus a metal gives us a salt, so I'd expect to get magnesium chloride plus hydrogen. And we detected the hydrogen with our little squeaky pop test. Zinc plus HCl appears to be going, but very slowly, so that would form zinc chloride, and if I could collect enough gas, then I could show that that was hydrogen. And I had expected to do that because one of the standard ways of making hydrogen gas in the laboratory is to use zinc metal. And we have to think about, well, why isn't my zinc working? Well, looking at my zinc here, it's inflammable, it's dangerous to the environment, and here is my zinc, you can see. Now maybe put a different light on it so you can see in. Maybe that's already reacted with something where it's getting old. The iron is reacting and we're forming iron chloride. Whether this is FeCl2 or FeCl3, I really don't know. And the odd bubble, so we were getting hydrogen gas given off. And copper plus HCl, well, it's just not doing anything. So we can try to put these metals and more in a basic series so we can look at what's going on. And if we want to try and remember the reactivity series, here's an idea that you might find useful. So we've got potassium, the most reactive metal we know, so we're going to put that one on top. And having done reactions of these, then we can see that sodium we knew was the next most reactive, and lithium, just by doing tests with the water. Then we've got, as another one, we've got calcium, and then we have magnesium. Aluminium, a metal that many people think is not very reactive. When we have aluminium, people think, oh, it's not reactive. I've got this aluminium foil, I wrap my food in it, put it in the oven, keeps my chicken from burning. Can't be that reactive. But in fact, aluminium is an odd metal. What it forms is a very small oxide layer on it. So you take the aluminium and very, very quickly, within a few seconds, it's reacted with the air and there's a thin, almost transparent layer of oxide. It's called a patina, protecting the aluminium. And this stops it reacting. If you want to look at aluminium reacting, then we need to get rid of that. And we usually get rid of that by either giving it a quick rub, or we can put it in a chemical to try and get rid of some of the oxide. And then we find that aluminium is a lot more reactive. Zinc, well, with zinc here is probably used most of the time for the laboratory preparation of hydrogen. So it's relatively cheap and it makes hydrogen in sufficient quantities. Not in my experiment. Iron, less reactive. And then we've got lead. And lead will just about react with the acid. And now I've got an interesting one. I've got here hydrogen. Now hydrogen is a very interesting metal. You see, where does hydrogen go in the periodic table? And I get a lot of people tell me that hydrogen can't be a metal, and it can't be a metal because it's a gas. And then I get them to think about that. And so I say, well, let's take mercury down here. And mercury can't be a metal because it's a liquid. And they go, oh no, that can't make sense, because these are just states. So hydrogen is a very odd material. Some periodic tables put it here with the alkali metals, saying it's a metal. Others put it somewhere over here because they can't really decide what it is. Hydrogen's a little bit odd. It's got some of the properties of metals and some not. Sometimes it feels like being a metal, sometimes it doesn't. But it has quite a lot of metallic characteristics, and so we need to think of it sometimes as a metal. Carrying on my list, then we've got copper. Well, that didn't react with acid. Well, that's not really surprising, because up here is hydrogen. Hydrogen is more reactive than copper, so we wouldn't expect anything to happen. And then we've got silver, gold and platinum. I brought this one out for you because this is a way of remembering the reactivity series. I like it, I'll tell you why. It's potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, silver, gold, platinum. Please send lions, cats, monkeys and zebras into lovely hot countries. Signed, General Penguin. Potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, silver, gold, platinum. May be useful to you. There are other ones, but there's an awkward non-metal that goes in here as well. We've got the hydrogen down here, but there is another one that causes a lot of problems, and we have to remember this one, and that is carbon. And we know that carbon is more reactive than iron, just slightly more reactive than zinc. So I could put in here carbon, and we can use carbon in the reactivity series because we use the more reactive with the less reactive to extract these things. Carbon, being more reactive than iron, can take the oxygen away from iron oxide, leaving me iron and carbon monoxide or carbon dioxide. We use carbon in the smelting of the iron ore because carbon is particularly cheap, and that's as good a reason as any. One of the reasons that England was so successful in the Industrial Revolution was that we were largely built on coal and iron ore, and this gave us an immense sort of advantage over many other countries. So we've got our reactivity series. Can you remember it? We've got potassium, we've got sodium, lithium. These are all group 1. Then in my list I've got calcium and magnesium. These are all in group 2. Then we have aluminium, group 3. Carbon, group 4. And then the list breaks down. Then we've got zinc, we've got iron, we've got lead, we've got hydrogen, and as far as I can tell, these are in no order at all. But the last ones, they follow a different order. Here I've got copper, silver and gold. If I put my periodic table here, I've got copper, silver and gold, and the next one, platinum, is next to it, so it makes a sort of a J shape. And that here, if you like, is going down the copper group. So we do have either mnemonics to help us remember what these things are. Please send lions, cats, monkeys and zebra into lovely hot countries, signed General Penguin. The reason we like this is the penguin, of course, because my son is fond of penguins, let's put it that way. So we've got here reactions of our metals plus acid to try and give us some sort of table, some sort of idea of the reactivity of these. Reacting metals plus water, we looked at these with water, and we can see these react with water, so very vigorously. I'm going to give that 5 ticks. Sodium is going to get 4 ticks, lithium 3 ticks, calcium 2 ticks, and I'm sorry, magnesium, it didn't react, but it will react if you can put steam in there. If we look at reactions here with acids, then I could start having a look at these substances. Aluminium, carbon, doesn't really react with acid. Zinc, just about did here. Iron, barely. Lead, just about. Hydrogen's not going to work because hydrogen is already the substance in the acid. It is the H in HCl. It's the H2 in H2SO4. It is the H as in the HNO3. If you want to try and get some of these to go, then we might need to have warmer acid. And then these here, basically no reaction. We've managed then to look at various different metals. We've looked at 4 metals, we put them in order. We could have looked at more metals to try and do this. We have looked at, in previous sessions, we've looked at potassium, we've looked at sodium, lithium, and we've looked at calcium and magnesium. So I didn't need to repeat those experiments because it's the same results, and we could put those in order. So we've got some idea about reactivity. Now our next thing, once we've done that, is to go on ahead and look at displacement reactions, and that's what we're going to do when we start next time. We're going to look at what happens when you put a metal with a salt and see whether they do swap or not, and this is all going to depend on this reactivity series. Some of you will be allowed to have a table with this stuff in. Others will have to learn that reactivity series, which is why remembering it as first of all group 1, then group 2, group 3, group 4, a mess, and then the copper group helps to try and stick it into your mind. I hope you found that useful. If you found that useful, then please subscribe, and I will see you the same time next week when we'll have a look at these displacement reactions. Take care, stay safe. Bye bye.